There are three parts to this example, example 8. So let's do it one by one. Find the range of values of k for which x squared minus kx plus 3 minus k equals to 0 has real and equal roots. Okay, so it has equal roots. So for the first part of the question, we know that this quadratic equation, x squared minus kx plus 3 minus k equals to 0, has real and equal roots. Okay, so has equal roots. So what does it mean to have equal roots? Okay, so I hope you remember, having equal roots means the two roots are the same. So when that happens, it means that our discriminant, our b squared minus 4ac, will be equal to 0. Okay, so let us now identify which is the a, which is the b, and which is the c. So for b, alright, it will be rather easy because there's a coefficient of x, so it will be negative k square. Okay, that will be our b square minus 4 a will be 1 because coefficient of x squared is 1, so 1 is as good as not being there. Alright, so c is of course the constant term, which is 3 minus k is equal to 0. So from here we can simplify and we will end up with a quadratic equation involving k. So this will give me minus 12 plus 4k is equal to 0. So you can actually very easily simplify this, factorize this I mean. So you'll be k minus 2 and k plus 6. Okay, so from here I suppose it shouldn't be such a big challenge to you. Okay, so k will be equal to positive 2 or negative 6. This will be the answer for part 1. Okay, now let's take a look at part 2. Alright, same equation, but now what is wrong with it? There is nothing wrong, it's just that now it has real and distinct roots. Distinct roots means they have two real roots that are different. So when you have two real roots that are different, it means that your quadratic equation will look like this graphically, isn't it? So you have two real roots that are different in value. So when this happens, it means that we are talking about our discriminant b squared minus 4ac being greater than 0. Okay, so again our b squared minus 4ac will be the same equation, okay, the same expression, the same quadratic expression that we have earlier on. So it will be k squared plus 4k minus 12 will be greater than 0. Okay, so let us move up a little bit. Okay, now of course what do we do from here? From here on, well, we factorize. So we factorize, we'll get k minus 2 and of course k plus 6. So then we draw, okay, we have a rough sketch of the curve. So we know that it will cut at negative 6, it will cut at positive 2, isn't it? So we want the parts of the curve to be greater than 0, so our k will be less than negative 6, which will be this part onwards, okay, or our k will be greater than 2, which will be this part onwards. Now what your answer that we have here means is that when our k is greater than 2, alright, and we were to substitute in k here, alright, we will get our b squared minus 4ac to be greater than 0. Now this curve that we have here has got nothing to do with the original curve, okay, which means that it's this curve here. Alright, now the curve that we drew is not this curve because we have no idea what is k. Okay, the only thing that we found out was that when our k is greater than 2, the b squared minus 4ac, alright, will be greater than 0. And as far as we know, we only know that this curve will look like this with two distinct x-intercepts. Alright? Okay, so now let's take a look at part 3. Again, same curve, same equation, x squared minus kx plus 3 minus k is equal to 0. So this is the same quadratic equation. But for now, I want the quadratic equation to have only imaginary roots. So to have imaginary roots means that this curve will look like this. Okay? With no roots at all. So when a curve that looks like this has got no roots, it means that our b squared minus 4ac should be less than 0. Alright, and that means, okay, we have worked out our b squared minus 4ac since part 1. You realize that we recycle, okay, the same expression time and again, so we're going to do that once more. So b squared minus 4ac will be k squared plus 4k minus 12 being less than 0. So again, what we do here, we factorize. Okay, and you may notice that, hey, we actually did the factorization for the second part. So it's actually k minus 2 and of course k plus 6. Alright, now the only difference here is that, alright, we're going to have the parts that's less than 0. So with the same steps, we're going to still sketch the same curve. Okay, it's going to cut at negative 6, it's going to cut at positive 2, but now we're looking for the part of the curve that is underneath the x-axis, the part that's negative. So it'll be here. So we know that our k value will be between negative 6 to positive 2. Now again, what does this tell us? This tells us that if our k value were to be between minus 6 to positive 2, we will have a discriminant value of less than 0, which means that our discriminant will be negative. Again, I want to highlight this to you, that this curve that we sketch here is not the curve, the original curve that we have. Okay, in fact, the original curve that we have should look like this. Okay, hovering above the x-axis if our k is between negative 6 and positive 2. So it is very important for you to understand what you are doing, okay, and what your solution means. Alright, so take some time to review this and make sure you understand fully what your answer is talking about, okay, and what you are actually doing. Alright, some people do the steps without really understanding, and I think that is not a very good way to learn. Okay, so when you learn it well, you make sure you understand it properly.